All right, so today we're going to look at section 1 of Unit 8. Unit 8 is all about trigonometry, and you've maybe done some of this in your previous classes. So some of this hopefully is going to be a little bit of a review, but there's definitely going to be new stuff, if not today, in the coming days. So diving right in, trigonometry is built often most around the right triangle. So you'll see here our first 3 examples all have 3 right triangles with pieces missing. So it's going to ask us to fill in the sine, cosine, and tangent ratios. Now, you may have learned those in the past. If not, you need to learn them now. So let's see, hopefully this is familiar to some of you. If I'm looking at sine, the sine of an angle, we're going to use theta as our variable for angles. So the sine of an angle is equal to the opposite side of the triangle divided by the hypotenuse. So the hypotenuse of a triangle is the side across from the right angle. So on this first triangle, we have our right angle down here. This missing side is going to be our hypotenuse. Cosine, let's use a different color here. Cosine of theta of an angle is equal to the adjacent side divided by the hypotenuse. Now, in order to have an opposite or an adjacent side, we need to be looking at one particular angle. So here, if I look at angle A right here, we know that this one over here is the hypotenuse. The side across from my angle, so if this is my angle, the side straight across from it, that's going to be my opposite side. Whereas the side next to it that's not the hypotenuse right here, this is going to be the adjacent side. So you have to be able to identify those, because then if I switch over, instead of looking at A, I look at angle B up here, those actually switch. The hypotenuse is still here, but the side across is going to be over there, right? So B, angle B is made up of 2 sides. The one that's not making up angle B is the one that is opposite from it. So again, that 12 is opposite B, opposite from B. So again, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent, our third trig ratio, tangent of an angle is going to be equal to the opposite side divided by the adjacent side. Opposite divided by adjacent. So now I have my 3 formulas. You may have heard a mnemonic device for these before. I'm going to go ahead and put this in. You can write it down wherever you've got some space. So right now I'm going to erase everything that I've done so far and give you the shorthand mnemonic device. You'll hear it called SOH, S-O-H, CAH, C-A-H, TOA. And maybe a teacher before had some little story to go along with it. However you want to memorize that, go for it. And the idea is, again, that sine, S, sine, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent, again, all of these of theta, technically, I should put that theta in there. I didn't put it on the others. Tangent of theta is opposite over adjacent. You must have these memorized in some way, shape, or form. So once we've got all that, the problem right now for doing our first 3 examples is that we don't have all 3 sides. We're missing one in each of these. To find that missing side, you're going to go back in your memory to, probably, I don't even know, junior high. When did you learn the Pythagorean theorem? Pythagorean theorem tells us that if I have two sides of a right triangle, A and B, that A squared plus B squared equals this third side, the longest side, the hypotenuse squared. A squared plus B squared equals C squared. So now I can dive in here. I've got 12 and 9, so I'm going to set these up to find my missing side, C or H. Again, you might want to call it H just as a reminder that it's the hypotenuse. So we're doing 9 squared plus 12 squared equals the hypotenuse squared, or C squared. You can call it either one. And now you can grab a calculator if you need to. 9 times 9, 81, 12 times 12, 144. And then that's supposed to equal H squared. 81 plus 144. That's going to make, and again, you're welcome to use a calculator for this. So if I'm adding 81 to 144, and again, hopefully you guys are following along and doing this on your own, that gets us 225. And so now if I need that final answer, I can take the square root. You will be allowed to use the basic calculators that are at the desks. You can take the square root of 225, and this one does work out quite nicely. We get 15 for H, or C, whichever one you want to call it. So this missing side right here is 15. And now we've done all the hard work. If I want sine of A, here's A. Sine is opposite over hypotenuse, so 9 over 15. Cosine of A is going to be the adjacent over hypotenuse. So adjacent right there, 12 over 15. And then tangent is going to be opposite over adjacent, 9 over 12. Now we're actually not quite done with those because they all simplify. So I can take 9 over 15, 3 goes into both of those, end up with actually sine of A being 3 over 5. Cosine of A, dividing both of them by 3 again, getting me 4 over 5. And tangent of A, 9 over 12, 3 goes into both of those, I end up with 3 over 4. So there's my sine, cosine, and tangent values for this triangle. I can also, though, look at it from the perspective of angle B. So I'm going to come up here. I'm erasing the 15, but I'll put it back there because that doesn't change. Once you've found that that side's 15, it's going to be 15 for the rest of this problem. But now looking up here at B, when it asks for sine, I'm looking at the opposite side, the one that's not touching B, and that would be 12. So 12 over the hypotenuse, 15. And then I can look at the adjacent side for cosine. Cosine of B would be the adjacent over the hypotenuse, so 9 over 15. And then last but not least, I can look at the tangent, opposite over adjacent, 12 over 9. And these numbers should look familiar to you. As far as the 12 over 15, 9 over 15, those are the exact things, same things we got for sine and cosine before, but they are switched. So let's go ahead then and reduce them just like we reduced the other one. So 12 over 15 becomes 4 over 5. 9 over 15 becomes 3 over 5. And 12 over 9 becomes 4 over 3. So that's the only one that's different. 4 over 3. The tangent of A and tangent of B are linked in that they're reciprocals of each other, because again, I'm just switching which one's the opposite and which one's the adjacent. So now, continuing on, when I look at the next triangle, I have the exact same thing, except now I'm missing one of the sides instead of the hypotenuse. So I'm going to set this up and say that I am looking for side A squared plus 8 squared equals 17 squared. And again, use a calculator, go ahead and do 8 times 8 is 64, A squared plus 64. 17 times 17 is going to get us 289. But now, instead of those being on the same side already and me combining them, I'm going to have to subtract 64 from both sides. Minus 64 both sides. And that gets me, well, look at that, 225 again. So a squared equals 225. And we already found that the square root of 225 is 15. So that missing side right here is 15. Let's go ahead and erase that work. Hopefully you've got it down. If not, check with the person next to you. Let's go ahead and erase all that. So we've got plenty of room here to do our work that's coming up. And we can fill in that missing side. Instead of the hypotenuse, though, this time it's just one of the legs of the triangle, is 15. Notice how the hypotenuse right here is always going to be the longest side every single time. If it's not, you did something wrong. So now, sine of A, here we are, we're looking at the opposite, 15 over the hypotenuse, 17. So 15 over 17, adjacent, 8 over the hypotenuse, 8 over 17. And then the tangent is going to be opposite, 15 over adjacent, 8. So 15 over 8. Now, the trick here is that none of these simplify. So this is actually our final answer for those three. Let's go ahead and switch, and let's look at angle B instead. So I'll erase this. So angle B up here, opposite side is now 8 over hypotenuse is still 17, adjacent side. And if you guys want to label these, when you're looking at B and you want to write, okay, this one's opposite, this one's adjacent, this one's hypotenuse, that's totally fine, as long as you remember that if you switch over to looking at A, you've got to switch to the adjacent and hypotenuse. So 8 over 17 for the sine, cosine, adjacent 15 over 17, and tangent is going to be opposite 8 over adjacent 15. There's our three values for angle B. Going on then here, I'm looking here at a triangle, same idea, I'm missing one side, so I'm going to use the Pythagorean theorem again. Hopefully you're getting pretty familiar with this now. A squared plus 24 squared equals 25 squared. Now, most of the time, we're going to end up with these working out really nicely, whole numbers, but not always. You're going to end up on occasion with square roots in your answer. Know that I want reduced square roots. You've had plenty of practice back in Unit 6 with reducing square roots. That is the assumed default way of writing your answer for any of these. So let's go ahead and do it. 24 times 24, 24 squared is 576. 25 squared, 25 times 25, try that again, is 625. Then I can subtract the 576 and get 49. Take the square root of that one, or a lot of you probably know it already. Square root of 49 is 7. That's our missing side, and we're good to go now with the rest of this problem. So I can go ahead, erase all that just in case we need the space. And now I can put these down fairly quickly. Sine of A, opposite. And again, let's label it this time. So if I'm looking at A, this one's the opposite. This one's the hypotenuse, again, because it's across from the right angle. This one's the adjacent down here. So opposite is 24 over hypotenuse of 25. 24 over 25. Cosine, adjacent over hypotenuse, 7 over 25. And then the tangent would be 24 over 7. And hopefully you can all go ahead then and fill in the ones for B. Go ahead and try that now, and then we're going to try a couple homework problems for practice.